Hey guys, what's up? My name is Noah. I'm glad you could watch this video. It's going to be a video over the problems in 6-6. I made a theorem video if you want to check that out, but this is going to be doing actual examples. And if you have the geometry book, go ahead and flip to page S15. It's going to be way in the back of your book, and you can kind of follow along. I'm going to be doing problems from back there. I'm going to go ahead and check and see all the different things. Okay, so go ahead and flip back there, and we're going to check this out. Gotta give me time. Okay, here we go. So we'll look at problem 37. And the book gives us an interesting setup. It gives us this kite, and it's flipped on this screen. It's different in the book, but all the variables will be the same. So we have T, U, W, V, and then this midpoint here is X. Okay, now the book gives us some interesting conditions. The book tells us that the measure of angle XTU is equal to 65 degrees. So the measure of XTU, so this is equal to 65 degrees. And in addition, it tells us that the measure of angle UVT is equal to 32 degrees. UVT. So this is 32 degrees. And it's asking us to find several things. So let's go ahead and go into problem number 37. Now what number 37 wants from us is it wants the measure of angle TUX. So T to U to X. So it wants this one. Now if you remember back at the theorems, the first one says that the diagonals of a kite are perpendicular, which is going to give us 90 degrees for all of these. So the measure of the three angles in a triangle add up to be 180. So we have 180 is equal to some x plus 65 plus 90, right? This is going to be the x in this equation. So let's go ahead and add the 65 to the 90, and that's going to come out to be 155. So x plus 155 rather. 180 is equal to x plus 155. You subtract 155 from both sides, and you get 5 to 60, so you get 25 is equal to x. So the measure of angle TUX is equal to 25 degrees. Now I'm going to go ahead and erase this problem here, and we'll go back. So now let me switch colors so it doesn't get boring. Alright, number 38. It wants the measure of angle XUV. So XUV. Same thing, 90, because, perpendiculars. So 90 plus 32 plus this angle is going to be 180 degrees, so that's 90 plus 32. So 122 plus whatever this is, so let's say x is equal to 180. So that's going to be 8 to 130, and then 50. So x is going to equal 58 degrees. And what I did is subtract 122. You get 122 by adding the 90 to the 32, and you get 58. All right. Now, I'm not going to go over, well, TWX. All right, I will. The next one is asking for TWX. So this one, now we've already found TUX, right? So it's going to be congruent. This is going to be congruent to this by the previous theorem. And so this is just going to be 25 degrees as well, because the first problem we did, number 37, we found that this was 25 degrees. Prove it. Side, 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 90 degrees, 90 degrees. You get the hypotenuse leg theorem. Congruent parts of congruent triangles are congruent, 25 to 25. And that's how you do it. let's go ahead and go over to a different example. And here we are. And we're given this polygon, or this kite rather. I'm going to check the time because I hate making these long because I know you guys don't want to spend all the time. So I'll try and speed it up here. Famous last words, but alright, so we have a isosceles trapezoid. And we're given that A is equal to 125 degrees. Wonderful. Now it wants us to find the measure of angle C. Now if you remember, in an isosceles trapezoid, opposite angles are supplementary. That is because you have, let's see, for this example we're trying to find the measure of angle C. We know that C is supplementary to B. Alright, so we know that these equal, that the sum of these equal 180 degrees. In addition, we know that corresponding base angles are congruent. So we have 125, so A is congruent to B. Now because A is the same as B, and B is supplementary to C, A is supplementary to C. So A plus C is equal to 180 degrees. 125 plus C is equal to 180 degrees. And that's going to come out to be 5 to 130. So it's going to be 55 degrees is equal to C. In addition, B would be 125 degrees and C would be 55 degrees. Alright, now let me clean this up. I'm going to go ahead and do an algebraic problem because I know you guys love those, and it's going to be having to do with diagonals. So we have this poorly drawn diagonal and this poorly drawn diagonal. And basically we are going to, we know that, let's see, this is number 43 by the way. Cross out these because we're going to change what the vertices are. We have a P, Q, N, and R. P, Q, N, and R. And we're given that RP is equal to 8y minus 7. So this whole thing is equal to 8y minus 7. So 8y minus 7 is PR or RP. So that whole thing is 8y minus 7. Now we know that NQ is equal to 10y minus 12. Alright, very cool. Now we want to find the value of y so that NPQR is isosceles trapezoid. Now, by the theorem, we know that the diagonals are congruent in an isosceles trapezoid. So we set 10y minus 12 is equal to 8y minus 7. Add the 7 first, just because we can. We're going to get 10y minus 5. Want to make sure. Yep, 10y minus 5 is equal to 8y. How else can we do this? I'm going to go ahead and subtract 8y from both sides. And that's going to come out to be 2y minus 5 is equal to 0. So 2y is equal to 5 because you add the 5. Subtract or divide by 2. Y is equal to 2.5. I believe that is how you would do it. Yes, y is equal to 2.5. Final problem. I know this has been a long video. I hope you skipped ahead if there's a particular example you're having trouble with. We're going to go ahead and do number 44. So we know that R, W, V, U, T, and S. We're trying to find RS. And we know that WT, well, first we know that these are congruent and these are parallel. And we know that WT is 25 and this one is 41. So, using the equation that we have, which I forgot to put in the theorems video, but anyway, I'll do it now. We know that WT is equal to 1/2 multiplied VU plus RS. And that is because W is the midpoint of VR and T is the midpoint of SV. And it's basically just the averages of the two segments. RS plus the distance RS plus the distance VU divided by 2 is going to give us WT. So we know that I'll do this the simple way. We know that 25 is equal to x over 2 plus 41 over 2. And x is simply resembling RS in this scenario. So 41 divided by 2 is 20.5. So 25 is equal to x over 2 plus 20.5. If you subtract the 20.5, we're going to get 5. We're going to get 4.5 is equal to x over 2. Multiply the 2's, and you're going to get 9 is equal to x. So I hope this video helped you guys out. I'm sorry I didn't prove the last theorem in the other video. Sorry this ran a little bit long, but I hope it helped. Have a good day.